Yo, we going to let's just wait for people to come in. Really hot chat. Thank you very much for joining the live stream. Uh, let's just wait for people to come in, you know. Set the camera a little bit. A bit there. Yeah. Whoa, how's it going, chat? To the live stream, chat. This live stream, we're gonna be building a project because I was unable to make the project. I was unable to post the video, which I said I'm going to be posting either on Sunday or Monday. So that is why I'm making this live stream for that project. Yeah. So all we are doing today is building that project because I didn't build the project the time I said I'm going to be building the project. So that's why I'm making this live stream today. And yeah, just looking for the best camera angle to keep this camera with best scene. Fantastic. Let's check out this section. How is this place look like? Oh, I'm sweating. Yeah, place is really hot, chat. Does this place look good? Okay, we're just gonna wait for people to come in actually. No one is yet out, so I have no viewers right now, so I'm just gonna wait. What I'm doing right now is just I wanna wait. Okay, we have one person. Yo, how's it going? Thank you very much for joining the live stream. Do all to give me a subscribe and like you to stay tuned to the end of this live stream because we're going to be building a project today, actually electronic project. So if you're an electronic fan, I'd like you to stay tuned. We're going to be interfacing with a Papa 5 timer IC chip, the NE Papa 5 timer IC chip. Yeah, that is what I'm going to be doing today. So if you're an electronic hobbyist, do all to stay to the end of this live stream because I'm gonna be imparting a lot of knowledge. I'm gonna be spreading a lot of ideas and things you need to know when you're working with this kind of component. Actually, I'm normally good. I'm supposed to post a video talking about this, but I have an issue with my phone, so I can't do edits. It's really hard to edit a video because the screen do touch other side. So that's why I'm making this live stream to make the project which I'm supposed to post as a separate video. So that is why I'm making this live stream. So this is the components I'm going to be talking about in this live stream throughout. The NE445 timer IC chip. Check it out. This is the NE445 timer. Let's turn on the light. The NE445 timer. This is actually an IC chip which is capable of producing PWM signals like this. It's capable of producing PWM signals. It has 8 pins, 4 at one side and 4 at the other side, and it counts from the left top to the right bottom. That is how you're going to count it when you want to like count the legs of the Papa 5 timer IC chip. That is the exact way which you are expected to count it. So in this live stream, we're going to be building an electronic project. We are going to be building a PWM signal. Yeah. Actually, I want to make a LED dimmer. If you are an electronic hobbyist, do what stay to the ending of this live stream to get full great insight and knowledge. I want to dim a LED. In my case, I want to dim this LED. Now this is actually a LED. It's actually a normal 3-volt LED, which is actually used in electronic projects for indication and all kind of stuff. But I want to like increase the brightness or reduce the brightness. To make that possible, I can just normally use a potentiometer to do that job. You can use a potentiometer normally to increase the brightness or reduce the brightness. This potentiometer is capable of reducing the resistance and increasing the resistance, thereby reducing the lead or increasing the lead. But in this case, using a potentiometer to connect with some bulbs which needs a lot of power will damage the potentiometer. So it's important that you use a PWM signal to make things more precise and make things more perfect. Normally you can use the potentiometer right here to just increase the lead, to increase the sorry, to decrease the lead or increase the lead brightness. But in the case where you need to increase or toggle a very high power lead, you need a PWM signal to do the job for you, because it's gonna burn the potentiometer which drives the lead. Because in some cases the potentiometer will not be able to sustain the current draw of the lead. Please do also subscribe and give me a like. Okay, now in making that possible, we are going to be using an IC chip, a 5x5 IC chip, and I'm going to be showing you a circuit diagram, how it works, and also the connection live right here. And we're going to be testing it out with a 5-volt power supply. Now the NE555 IC chip is a PWM chip which are going to be connecting in a stable mode to produce a square wave for us, on and off. Square wave is actually a frequency. And to make my project more unique, I'm going to be producing very high frequency out of this out of this 45 timer IC chip. In my case, about 48 kilohertz out of it. The reason why I'm producing this kind of high frequency is because I want to sustain the light steadiness even when I'm reducing the brightness. You know, when the frequency is very low, when you're reducing the brightness of the LED, the bulb will flick, like it will be flickering. So the reason being that I'm making the frequency very high, so that even though I'm reducing the LED brightness, the LED is still going to be stable and it's not going to be like flickering the way it normally it should be. So that is why I am using very high frequency produced out of this chip, and also some other few components like a capacitor, resistor, and jumper wires and breadboard for connections. Yeah, normally you need to use breadboard for connection to get it connected and all those kind of stuff. So yeah, so just give me a sec. Let me share the live stream. Okay. Stuff to make things, to wrap things up and make the project possible. So without this component, it's not going to be possible to make the project. So these components works in hand with the copper 5 timer IC chip to make it work and produce the frequency. And also I'm going to be using my meter to measure the frequency for you at the ending, so that you can be able to prove it and be sure that it's actually producing the exact frequency and the current draw and this kind of stuff. So let's quickly go to my decks. We have been explaining how does this actually works, and if you're joining the live stream right now, do to give me a subscribe, and let's go to join my journey and reaching 200 subscribers, and also give me a like. I really appreciate that. So let's quickly go to my decks. We have been talking about the 455 time IC chip and also how it works in the PWM signal and all this kind of stuff. Okay, let's close these things up. Let's go down, stick in there. I made a separate video for this, but can't edit chat. Okay, I'm gonna be holding the camera like so. Okay, now this is the circuit diagram which is gonna be like explained right here, and this is the 555 time IC chip right there. This is the 555 time IC chip, and it's the pins are counted like this from the left from the left top to the right bottom. That is where it's counted. I don't know if you can see the connections well, like this: 1, 2, 3, 4 from the bottom, 5, 6, 7, 8. So if you're making a project, don't miss this counting steps. If you count it wrongly, you're gonna connect it and you're gonna fry your chip. So just bear in mind about that. Okay, sorry for the delay. Okay, now these are the components which are used in the project, such as the capacitor, capacitor 1, capacitor 2, and resistor 1 and resistor 2. Now these components are put together to make the circuit working, and also the circuit is powered by 5 volts and also ground. This is ground connection. This is ground. This is ground connection. This is ground connection. This is 5 volts, and this is output pin 3, which is going to be connected to the LED to dim or increase the brightness. And here is how it works. Normally this is actually a PWM signal. This is actually a stable mode connection, and this profile time is capable of producing a PWM signal either high or low. And here is how it works. The power supply goes to the chip itself, and actually there are two resistors right here. The resistor one right here enables the circuit to pull up. Yeah, this is actually a pull up resistor to filter out static electricity in the circuit. Now resistor 2 right here is actually a potentiometer, which is going to be used to control the dimness of the bulb, either increasing the brightness or reducing the brightness. The also the RO2 right here, the resistor 2, is available for charging and discharging the capacitor. Yeah, without this resistor 2 right here, the capacitor cannot charge and the capacitor cannot discharge. So with the help of the resistor 2, that helps the capacitor to charge and discharge. As you can see right here, the capacitor charges. This is the capacitor which charges to resistor 1 and resistor 2, and this is actually 102 pf. Sorry about the 103 which I write right here. It's actually 102 pf, 102 pf. This capacitor right here, which is connected to pin 4, is actually used to filter out some fluctuations in the circuit, like fluctuations in the power line, like some disruptions and other frequencies, to make it smooth. DC power supply, this capacitor is needed for that work, and that is how the circuit works. Actually, the first pin right here is actually ground. The second pin right here, which is pin 2, is actually trigger. The third pin is actually output. The fourth pin is actually reset. The fifth pin actually here is actually control voltage. Yeah, it's used to control the voltage, stable the voltage. That's why I added a capacitor to ground to smooth the power supply voltage. Now this pin 6 right here is actually threshold. This is connected to the potentiometer for charging the capacitor or discharging the capacitor. The pin 7 right here is actually used to discharge the capacitor, like so. The capacitor is connected to one side of the potentiometer. This is actually the wiper right here, and is discharged through this side. This is actually pin 7, the discharge pin. And also this pin 8 right here is actually VCC, which is connected to power supply, VCC 5 volts, and also the other leg of the resistor is connected to the VCCs to serve as pull up in the circuit. Hope you understand what I'm talking about. If you really have any questions that you don't understand what I'm talking about, let me know in the comment section below, and I will restart it immediately. Without wasting much time, let's go into the circuit diagram and the circuit connections and every materials you need. So I'm going to close this book right here. I'm going to keep it aside. Oh, sorry about that. And this is the circuit. I once made the project. Yeah, I once made the project. So I'm going to scatter everything up and restart it and make. Oh my god, I left the 4-5 timer in the book. Let me get it. Just hold on a sec. Hold on a sec. Subscribe before you leave the live stream, please. Okay, I got it. Okay, now I'm going to disconnect everything. I'm gonna disconnect all the things I connected, and I'm gonna like connect it back and show you the steps on connecting it. You know what I'm saying? So yeah. So I'm gonna open my diagram for reference so that I won't make a mistake. Normally I can connect it offset, but just for you guys to know that what I'm writing in the book is what I'm connecting in the circuit. So you make your own and it will work also. You can get the circuit and make it at home, make it as a project. If it work for you, it must work for you. You know what I'm saying? Please do also give me a like on the live stream. Yo, thank you very much for joining. Give me a like and subscribe, and stay tuned to my project on building a PWM signal generator using an E555 timer. Okay, I got done. Should I make the live stream in the morning? I got a lot of views in the morning most times than in this period of time. But anyways, it is what it is, Chad. Don't forget to put some kind of just give me a sec, Chad. Give me a sec. Give me a sec. Let me just do something. The connections of the project. Now look at it. Now this is the breadboard she's using the project to connect everything together and to make the connections perfectly and well solid. And this is my 5 timer right here, which I'm going to be using on this project. And I'm going to insert that right away. Like so, I'm going to stand. I need to stand my camera so that I can be able to use my two hands. So just give me a sec. Just give me a sec. Let me wrap that up. Let me set my tripod for me to stand it. Yep. Sorry about the mistake. Okay, let's get that standing chart. Okay, yeah, this is my breadboard, and I don't really know if you can see it well. I hope you do. Yeah. Yeah, thank you very much for the clue on Power 5 Timer. It's actually a useful tool in electronic history. And thank you very much for joining the live stream. I really appreciate that. Okay, now this is the breadboard which I'm going to be using in this to wrap things up. Okay, now I'm going to put my Power 5 Timer IC right here. You can put it anywhere on the breadboard, anywhere that it's meant to be, like so, like this. Then according to the circuit diagram, if you don't really get the circuit diagram from the beginning, do well to go back and check it out. Yeah, do well to go back and check it out. Okay, as I said earlier, the first pin of the 5 timer is connected to ground, like this. This first pin of 5 timer is connected to ground. Now there's something you need to know about breadboard. This blue side is actually ground, while the red side lane is actually positive. So it's actually VCC. This red part is VCC, while this blue side is actually ground. So the one is going to be connected to ground as listed in the circuit diagram, and pin 2 is going to be connected to pin 6. I forgot to talk about that in the circuit diagram. It's essential, and it's how the 4-5 timer actually works. So pin 2 is actually connected like this. Check it out. Pin 2 is connected to pin 6. So this is pin 2, 1, 2. Now we're going to count 6 like this from the bottom. 5, 6. So this is 5. So this is 5 and this is 6. So pin 2 is connected to pin 6. Don't miss that. So this is the first connections. And pin 3 is actually the output of our power 5 timer, which is going to be connected to the positive side of the LED. And the negative side of the LED is going to be connected to the negative rail of the power supply, like so. See it right here. the positive side to the pin 2, the negative side to the negative rail of the power supply. And they're going to insert our potentiometer right here. Exactly the center pin is actually the wiper pin. The first pin and the last pin is the like a normal resistor, two terminals, but this center pin is actually the wiper pin, so don't forget about that. And you know, get that. No, you need to know all these things, right? So normally one side of the potentiometer is connected to one side of the potentiometer is connected to the VCC, the other side is connected to the pin 6, I guess. Yeah, it's connected to pin 6, and the other side of the potentiometer is connected to pin 7, which is also which also our one is connected to. And the resistor which I'm using in this video, in this live stream, is actually 10 kilo ohms. So we're going to be using a 10 kilo ohms resistor, and the two capacitors which I actually used also is the 103 PF capacitors, one for filtering and one for the discharge and charging. Say hello later. I'll see all of your live. Hi friend, I came to say hello. Later I'll see all of your live. Wonderful explanation and about so 4-5 timer. It's a simple and useful. I see. Yeah, see what? See. Nice one, chat. Okay, and also pin 4 is actually connected to positive side of the power supply. So that is also essential. Don't forget about that. Oh, I'm supposed to. Like so. Pin 4 of the 4-5 timer is going to be connected to pin 4-5 timer is going to be connected to the positive side of the power supply, like so. And pin 5 is going to be connected to the capacitor 1, which is used for filtering in the circuit. So it's going to be connect. One leg is going to be connected to pin 5. This is pin 5 right here. One leg is going to be connected to pin 5, like so. Please follow me exactly the way I'm connecting my own to get your frequency exactly. And the other leg of the capacitor is going to be connected to ground, and I'm going to be using this wire to make that possible. So just going to twist it a little bit like this, insert it here, then move it over to ground. Yep, as so the other side of the capacitor is actually connected to ground. Simple and short. And we are going. Now the first pin, the pin 6, is actually connected to two things. The pin 6 is actually connected to one leg of the capacitor, which actually charges and discharges through the R2 resistor. And also that pin 6 is connected to the wiper side of the potentiometer. The wiper side means the center pin. So the center pin of the potentiometer is always the wiper. So don't forget about that, and you should know all these things so that you won't miss your connections. So to make that possible, firstly you're going to be connecting the wiper side to the pin 6 of the IC. So I'm going to be using this wire to make that possible, like so. We're going to put it in the center. This is actually the wiper side. Sorry, my camera is not really capturing it, but you should understand, chat. So the wiper side is going to be connected to pin 6 of the 5 timer IC chip, like this. So check it out. Pin 6. Done. And also that pin 6 is going to be connected to one side of the capacitor, which actually charges and discharges in the circuit, and the other side of the capacitor is also connected to ground, as shown in the circuit diagram. Check it out. The capacitor which charges and discharges is connected to pin 6. This is where the 5 timer is. This is 5 and this is 6. So it's connected to pin 6, and the other side of the capacitor is actually connected to ground. So let's make that possible. We're going to be connected to pin 6, and we're going to be connected to ground. The ground is actually this place. You know, recently in the live stream I connected this other leg of the first capacitor to ground. So this capacitor which I connect to pin 6 is actually connected to ground, as so. I don't know if you can see it clearly. So see, you can see they're in the same rail. So that's it, to make your work more efficient and more simple. And as we go on, we're going to be introducing the R1 resistor, which is the 10 kilo ohms resistor. Please do want to subscribe to this channel to get me to 200 subscribers. I really appreciate that, and also give me a like if you enjoyed the live stream. And if you're a hobbyist, electronic hobbyist, do want to stay to the end because it's very important to get this, in fact, and knowledge. So this is actually a 10 kilo resistor which I'm going to be using in this video. In this live stream, I bent it this way so that it will be able to fit in that kind of small side which I'm putting it. So normally the one leg of the 10 kilo resistor is actually connected to P8, which is also connected to VCC, and the other side of the 10 kilo resistor is actually connected to pin 7. So this is it. This is pin 8 and this is pin 7. I don't know if you can see it clearly. Pin 8 and pin 7. So you're going to insert it like this. So if you want your resistor to fit in a small tiny place, you can bend it like my style. It's really nice and efficient. So yeah, it's inserted. You can see it. Pin 8 and pin 7. That is where it's insert. Very nice and clear. Follow my steps and you will get your circuit working. Fantastic. As I said in the intro of the video, this 5 timer project produces around 48 kilohertz to make my bulb steady, even if I'm reducing the brightness of the LED dimmer. Remember, we are producing a LED dimmer in this live stream using a PWM signal instead of just a potentiometer, which can get burnt in the process. I really appreciate the likes. Thank you very much. Do all to also give me a subscribe so that you can see when I post my latest videos. Yeah. Okay, let's go into the next connections. Now, also the pin 8 is actually connected to positive side, the VCC. Don't forget. So this is pin 8 right here. Pin 8 right here is going to be connected to VCC. This is the VCC rail. Go inside it so like this. If you have any questions on what you don't understand, let me know in the comment section below. Okay, done. Now what again? What is next? Are we done with the circuit? Are we done? Are we done? Are we done? Are we done? Okay, no, we are not done. We are not done connecting the potentiometer. Okay, now the first one leg of the potentiometer is actually connected to pin 7, and the other leg of the potentiometer is connected to power supply VCC. So be aware of that. So so we're going to be connecting it like so. So one side of the potentiometer, am I connecting it right? Yeah. One side of the potentiometer is connected to the pin 6, right? Okay, pin 7. Pin 7 is actually right here. This is pin 8. This is pin 8. This is pin 7. We're gonna put it like this. Pin 7. And the other side of the potentiometer is actually connected to VCC. We're gonna use a wire for that. We're gonna use this wire to connect that. Let's see if it will reach. Will it reach? Yeah, it will reach. So we're gonna insert it like so. We're connecting it to VCC. Oh my god, it did not reach. Let me use a longer wire to make the connections. So one side of the potentiometer is connected to VCC, also VCC, so the positive side, and the other side of the potentiometer is actually connected to pin 7. Don't forget. I'm going to show the connections at the end of the live stream when I'm done with it. Physical connections, so stay tuned to get the full connections. So so pin 7. It's really hard for it to end, so I'm going to use a jumper wire to push the wire in. Okay, we're progressing. Okay, done and fantastic. The potentiometer is connected successfully. One side of the potentiometer is connected to the VCC. The other side of the potentiometer is connected to pin 7, and the wiper side, which is the center pin of the potentiometer, is connected to pin 6. Don't forget about that. And the potentiometer is used to increase the brightness of the LED or reduce the brightness of the LED. And according to the way you turn the potentiometer, increases the duty cycle or reduces the duty cycle, and that is how it actually toggles the LED brightness either high or low. The explanation is that when you turn the potentiometer to the VCC, when you turn the potentiometer to the VCC side, it's actually increasing the time which it's actually increasing the time which the capacitor charges, and when you turn it to the pin 7, it reduces the time which the capacitor charges, and thereby toggle the dual cycle. If you don't agree with me, let me know in the comment section below. In my own understanding, that is how it works. You should know that as electronic always. I have only 2 people watching for how many minutes right now? 31 minutes. Well, it's something. Do well to give me a subscribe and let me know if you enjoyed the live stream. Okay, I think we're done with the connections. It's time for testing, chat. Let's see in the circuit if I missed anything. Did I miss anything? No, no, no. Just give me a sec. I'm actually checking the circuit diagram if I missed anything. So, okay. I think everything is connected. Let's make our first test and see. So to make that possible, you're going to be using the power bank. I'm going to be using the 5 volt to power the circuit and okay. So this 5 volt side is actually positive and negative. It's going to be connected to the breadboard, and to make the circuit work, it just okay. Just making some arrangements. Don't mind, but I'm not making any new connection. Just arrangements. I'm saying. That. What I observed is that I connected the rail of the power supply stopped here. You can see the stop. You can see where the color stopped, and I connected some components right here. So I moved the connection to this place where the rail stopped, because this side is not connected. This side is a different part. This side is a different part. Why this side is a different part? You can see where the thing stopped. So that is why I moved the connection to that side. So that was the arrangement I was making. So let's power the circuit and let's test it out. Okay, I hope it works. I'm gonna go into the dark and also test it out. So this is the positive side. It's gonna be connected to the positive side of the power supply, like so. Let's put it in like this. Okay. It's connected to the positive side of the power supply, like so. And the negative side of the power supply is connected to the negative rail of the circuit, like so too. Supposed to be using a transistor check. Oh my god, my phone is really hot. Okay, let's push it in. Let's use some jumper wires to push it in to make it tight. Sorry about the background noise. It's a lot of construction every blessed day, chat. Okay, connected successfully. Let's test the circuit and see if it works. I hope it do. Okay, the bulb turns on very bright at first, which I don't know why. So let's try to toggle the potentiometer if you can increase or reduce the brightness of the LED. I'm going to firstly turn it anti-clockwise and see. Oh, it works. It works. Oh my god, chat. Look at it. I can control the brightness of the LED. Wow. You can see it's still flickering because of the frequency is not that high. So if you want it to be very smooth, even though you reduce the brightness of the LED, you just have to make a very you just have to produce a very high frequency out of the 5 timer IC chip. Oh my days. Never knew this was gonna work so fast though. Fantastic. Oh my god. Just write, give me a congratulations in the comment section below. I really need it. Thank you very much for staying today. Till the time the project works. You can see it. It works, chat. Turn off the light. It works. Check it out. I can control the brightness of the LED like this. Okay, it's more bright. So if I can reduce it. Yeah. Oh my god, Chad. Fantastic. Yeah. Now, the advantage of this circuit, which everyone wants to hear. Yeah, the advantage of this circuit is that using a normal potentiometer to just control the LED brightness, it's also good and fantastic to make. But in the case of controlling a very high power LED, a very high LED which draws a lot of power from its source, it's going to damage the potentiometer, and that is no, that is bye bye for you. So your potentiometer is going to fry up. So using a PWM signal is a great choice, and I think that is what most electronic hobbyists do in making some upgrades at their home and all those kind of stuff. And I guess that is what is inbuilt in some electronic products to increase the brightness of the LED. If you have encountered in any LED dimmer, you can open it and check it out. It's actually not just the potentiometer to control the LED brightness. It's definitely a PWM signal or some kind of different frequency production to make things easier for them. I guess so. Please, my circuit works fantastic. Do also give me a subscribe. I really appreciate that. And I want to get to 200 subscribers, so do also be part of that. And I guess the circuit works. I was normally supposed to post a normal full video, maybe 10 minutes long, talking about this project, but I got really troubles on editing it. Like, I got the really troubles on editing the video, like, try to type something. Yeah, thank you. Good job doing it without an Arduino. That's a great, fantastic thing. Normally, you can use an Arduino to make this possible. Normally, you can use an Arduino to produce the frequency, all this kind of stuff. I make a lot of electronic on my channel, but in this video, I just want to interface with DIY electronics. So normally, as I said earlier in this video, sorry about that cut of my internet. So if you have ever encountered LED dimmer device at your home, do how to open it out if it's broken, check it out and see if it's actually potentiometer. Prove me wrong, and then come back to my life and comment. Yeah, sorry about the cut short. My internet connection was really bad. So yeah, I made the project. Fantastic, right? Ah, thank you very much for staying this long to the ending of my project and producing it and everything. It's really a nice thing to do. I want to say thank you so much. I really appreciate that. And also do also give me a subscribe and like the video if you like my project and you want to support me on my future making videos. Do also check out my link in the bio on my bio to support, and also if you want to wrap things up, check out Patreon at Successful Electronics. Support it anything you can. Thank you so much for that. And let's test the circuit one more time. So this is the circuit. I'm so glad it's working. 555 timer based LED dimmer. So if you made this project, let me know in the comment section below if you have made this project. If you have made this project, let me know in the comment section. It just works the way it would have worked. Check it out. Don't know if you can see it clearly. It's working fantastic with just few components instead of using an Arduino chat. You can make this with just simple. I can even make this with a transistor, I guess. Can I? Can I do it with a transistor? Should I make it with a transistor? Let me think for a sec how it sounds. I think I'm going to be using two transistors to make that possible. One is for increasing the lead and one is for decreasing the lead. You know what? I'm going to think about that and I'm going to practice it and see if I can make the project. Thank you very much for staying to the ending of my project. I really appreciate that. And also, I think that's all for now. And that is why I came live today to just make the project, because I'm having a lot of issues on making the full video. Normally, this is just a short live stream because it's not a normal live stream. It was actually a first live stream because normally I'm supposed to make a separate video for it, like to post a separate video talking about this project, how it works, and also the circuit diagram, everything you need to know about the circuit. But because of having issues with my device, I have to like make the live stream, test it out live, and you know that I don't make false project. All my projects are legit. So should I make it to the transistor? Let me know in the comment section below, and I will do that maybe some other time. So let me know where you're watching from, and also give me a subscribe to get me to 200 subscribers before the ending of this month. I really need to get to 1,000 subscribers before the ending of this year, and that is my goal. So support me, chat. Support me get to that. I actually thought of thank you, guy. I actually thought of the fuck. Oh, I mistakenly deleted a message. I deleted the message. Oh my gosh. I mistakenly deleted the message. Oh my god. Oh shit. Uh, I mistakenly deleted the guy's message. That was a mistake. I'm so sorry. I wanted to pin the message. So sorry about that. So great, fantastic project, fantastic journey making a LED dimmer using 5 timer IC chip instead of using a normal Arduino Uno, which you can use also. So fantastic project. I really appreciate all your support, and thank you very much for subscribing to this channel. And also, I said I'm gonna test the project in the dark, so I'm just gonna close all the windows, test the project in the dark, and you're gonna see the main dimming procedure. Do all to subscribe to my channel to get me to 200 subscribers. I really appreciate that, and let's wrap things up and make that possible. So yeah. So just hold on a sec. Let me close all the windows so that I can be able to test the project in the dark. Oh my god. Damn. No, I don't have lights, chat. I literally have to open everywhere to get enough lightning. It's not that good, but anyways. Okay. Things everywhere is sealed up. Let's test it out. Okay, this is the project, and we're gonna off this light right here. Check it out. I increase it. You can see it. You can see it, chat. You can see it. I reduce. I can reduce. I can increase. I can reduce, I can increase, I can reduce, I can increase, I can reduce, I can increase. Fantastic. Okay, now here's also another tip. You can power this for 5 timer between 5 volt to 12 volt. So you can power a 12 volt LED right here also. And if you're looking towards producing or powering a much larger lamp, which you cannot do with a normal potentiometer, you can connect the output of the 5 timer to a transistor. Then act the transistor as a switch, connecting that large LED lamps which draw a lot of power, and it's gonna solve. You can use this transistor. Maybe this transistor can draw up to 1 amp B772. You can use it if you want to power a large lamp. So that is just an in case, and that is an idea which I want to share with you. Thank you very much for staying to the ending of this live stream. I really appreciate you, and I'll catch you next one. Do subscribe to my live before you leave the live stream, and I thank you so much for you staying to the ending, from the beginning to the ending. Do have to practice the project, and bye. See you in the next.